Chemical test of carbonyl compounds. Reddys test is used to identify C double bond O in a compound, means it can detect aldehyde, it can also detect ketone because both class of compound has C double bond O. The Reddys reagent that we use in this Reddys test is 2,4-dinitrophenylhydrazine in methanol and sulfuric acid, means it must be in acidic condition and must be the presence of alcohol. If there is C double bond O in the compound, the orange precipitate will be formed. For example, ketone we have here reacts with 2,4-dinitrophenylhydrazine in methanol and acidic, so the orange precipitate will form. Means we remove this O and H2, remove H2O, remove H2 and then O here, so C double bond N, one that we learned in condensation of ammonia derivatives. This is one of the ammonia derivatives, so the product will be C double bond O, O is removed, and H2, H2 is removed, C double bond N. Attach this C with this N, so C double bond N, and then copy back whatever you have in here, a dinitrophenylhydrazine. So this is the orange precipitate color. Okay, these are different types of orange precipitate, depends on the reactant that you use, and here we have glucose, this kind of orange, aldehyde, slightly light yellow but still in orange, but more to yellow, and then this we use acetophenone, ketone, this kind of orange. So orange precipitate will form, but the intensity of the orange depends on the reactant that we use. So if there is C double bond O in the compound, the precipitate, orange precipitate will be formed. At the product you can see the orange precipitate. Next is tolens test. Tolens test is also called silver mirror test. This test is used to identify aldehydes only. Cannot identify ketone. Only use the tolens test to identify aldehyde. The tolens reagent that we use is silver 1 oxide in aqueous ammonium hydroxide. So this is the correct way to write ammonium hydroxide, square bracket, AgNH3 2 plus OH minus, close the square bracket. This is the right way to write ammonium hydroxide. So silver 1 oxide in ammonium hydroxide. If there is aldehyde in there, silver mirror will be formed. Here, for example, aldehyde, AgNH3 2 plus OH minus. The product is carboxylate ion. The C double bond O, and then you remove this hydrogen here, attach it with O minus. This is carboxylate ion plus Ag silver. This is silver mirror, silver precipitate, arrow pointing downwards because precipitate will settle down at the bottom of the test tube. Next, Fehling's test or Benedict test. We use this test to identify aliphatic aldehyde. It cannot identify ketone, it cannot identify aromatic aldehyde. It can only identify aliphatic aldehydes. The reagent is copper 2 complex in basic solution. So what is copper 2 complex? In Fehling's solution, making copper 2 complex, we use solution of copper 2 sulfate and mix it with or combine it with potassium tartrate tetrahydrate and sodium hydroxide. Note that in basic solution, that's why we add sodium hydroxide. So add these two, mix them together, combine them in NaOH, it becomes Fehling's solution. And if you want to make benedict solution, a single solution of copper 2 sulfate, we're still using copper 2 sulfate in both Fehling and benedict, copper 2 sulfate, but In benedict, we reacted with sodium carbonate or sodium citrate buffer. This is basic as well. Okay, both is copper 2 complex. So if there is presence of aliphatic aldehyde reacts with copper 2 complex in basic solution, the product will be carboxylate ion, same as the silver mirror test. The product will be carboxylate ion, but the side product is Cu2O. This is brick red precipitate, arrow pointing downwards because precipitate settle down at the bottom of the test tube. We know that copper 2 blue in color, whether it's Fehling's or Benedict, because both use copper 2. So blue color solution decolorized. If there is aliphatic aldehyde, the blue color solution will be decolorized and brick red precipitate form. This is the brick red precipitate, not the carboxylate ion. Same goes to the tolens test. The silver mirror is this silver, not the carboxylate ion. Next is Schiff's test. This one is to identify aldehyde. Reagent, aqueous solution of fuchsine and AHSO3 and HCl. This is fuchsine. The solution of NaHSO3 and HCl, or we call it Schiff reagent. This reagent must not be heated. If you want to do Schiff test, don't heat NaHSO3 and HCl. It is used to identify aldehyde. It cannot identify ketone, negative result for ketone, but propanol will give positive result for Schiff test. So you have to memorize this. Schiff test identify aldehyde, but it also identify propanol, and it cannot identify aromatic aldehyde. Okay, only aliphatic aldehyde. Aromatic aldehyde, Schiff test cannot identify aromatic aldehyde. The observation, pink coloration form. This is an example of pink coloration. For Schiff test, for propanol, it shows the positive result for propanol, but if you use Schiff test to detect propanol, it is extremely slowly. So you know that if Schiff test gives the positive result, but if it's very slow, that is propanol, because it won't detect other ketones, only propanol, but it is very slow. Next, iodoform test. Iodoform test for methyl carbonyl, detect methyl carbonyl. In alcohol, iodoform test detect methyl carbinol, but in carbonyl compound, it detect methyl carbonyl. Same reagent for iodoform test as in alcohol. We use excess iodine and AOH. Observation, yellow precipitate form. If the carbonyl compound C double bond O, if that C has methyl group, then this is methyl carbonyl group, and it will give positive result for iodoform test, excess I2OH minus. The products are carboxylate ion, the C double bond O and then C single bond O minus, plus CHI3. This arrow pointing downwards means the yellow precipitate form at the bottom of the test tube. So this iodoform test, here is methyl carbonyl. Methyl carbonyl. So it has methyl carbonyl, it will give positive result for the iodoform test. This is the yellow precipitate. This is example of yellow precipitate. These are the summary for chemical tests for carbonyl compounds. Overall, we have reddys test to identify both aldehyde and ketone, because it only identifies C double bond O. And then we have Fehling's or benedict test. It will differentiate aliphatic aldehyde from aromatic aldehyde and ketone, means the Fehling's or benedict test give positive result for aliphatic aldehyde. And then tolens test only detect aldehyde. Observation, silver mirror. Shift test, it will detect aldehyde, same like tolens test. Shift test will detect aldehyde. Iodoform test detect methyl carbonyl group. Yellow, light yellow precipitate form. This is methyl carbonyl group. C double bond O has methyl group. Thank you.